Welcome back to another episode of the Additive Snack podcast. I'm your host, Fabian Alefeld, and today we're venturing into the interface of additive manufacturing and artificial intelligence. Joining us, therefore, is Omar Fergani. Omar is the co-founder and CEO of 1000 Kelvin, a company that is at the forefront of really an AI-driven revolution in the additive manufacturing industry. And that means today we're going to explore the depth of the innovations that are driven by 1000 Kelvin. We'll understand the pivotal role that additive manufacturing really plays in additive manufacturing without the buzz and the whistles. And we'll get a glimpse into the future of AM with the solutions that we'll talk about today. So without any further ado, Omar, welcome to Additive Snack.
Fabian, thank you for hosting me.
So let's start with the easiest question of today. What do you guys do at 1000 Kelvin?
Awesome. That's the hardest one. We first of all, really excited to be here. I really appreciate the work you're doing, Fabian, and I'm looking forward to clarify a few topics and contribute to the community. So 1000 Kelvin is an AI technology company focused on additive manufacturing and advanced manufacturing generally. We're based in Berlin, but we are also now in the US. Very proud to be between two great technology nations, benefiting a lot from that. And we are developing AMAIZE. And what AMAIZE is the first co-pilot developed and designed for engineers in the additive to bring as much knowledge, as much iterations, as much trial and errors from the physical world to the digital world. So we use machine learning models to help engineers see what's going to happen within their components, understand the intricacies of geometry, the influence of the parameters, try to look at the thermal issues upfront, and provide them also with solutions so that they can solve them and maximize the number of digital iterations and not physical iterations. The outcome is very simple. Engineers can do way more in a shorter time, can understand better their designs, their processes, and ultimately, AMAIZE is meant to really unlock some of the challenges in the additive. So our real focus is enabling the engineers so that the companies can start scaling and go to domains that were not possible.
Mm-hmm. Very, very interesting. When a lot of people talk about AI, especially in the mainstream media, there's oftentimes this notion of, well, how many jobs will it take away? Which jobs will it take away? But I think it's very interesting that you're talking about AMAIZE as a co-pilot, meaning the ultimate intention is to make engineers more efficient, reduce physical iterations, speed up innovation time. Has that been the goal from the beginning, or did you realize that that's just such an efficiency booster for engineers as you develop this platform?
Well, perhaps to answer a question, let's go to the beginning. I'm an engineer. I have started my career designing advanced drilling systems in the Houston area for the oil and gas, and I was exposed to AM quite early on. So I have hands-on experience on the process. Not only I was an application engineer, I also joined Siemens for many years, where I was in charge of building software to reduce the number of physical iteration using traditional finite element technologies. So it was clear for all of us, not only for 1000 Kelvin, but all of us as a community, that we need to leverage digital technologies generally to bring speed and more precision in what we are doing. So you bring the keyword here, AI, which is obviously the core of what we're doing. We're a team of AI experts, physicists, and we're building these groundbreaking models that are enabling AMAIZE to do what it is doing. However, it's not only AI. There is a full trend that is happening over the last few years that we have been able to capture. There is the reduction of the cost of compute thanks to cloud. The advances in physics-based simulations. And AI comes as a result of this. We have a joke internally in the company. We say physics-based simulation of finite element was not made for engineers. It was made for machine learning. And that's what we're doing. So now when we say co-pilots, when you bring AI to a heavy industry, an industry that is in the physical world, it's extremely hard to say that you will reduce jobs or amount of engineers. As a matter of fact, we need more, and there is a massive shortage,
Exactly.
and we all know that. What are we talking about here? In our industry, a copilot is necessary, and not only in AM, in every processes. So I don't think there is a risk for engineers, and we're actually have massive experience with our users. They see it as a copilot. As a matter of fact, I didn't create this word. My customers call it a copilot. So that's from that perspective. This said, I don't want to say that AI does not have an influence on our society and there will be impact, et cetera, et cetera. But specifically for our industry, I think it's the name of the game.
Yeah. I mean, before we clicked record, we talked about declining birth rates, and it's very interesting that, we definitely have we don't have enough workforce in the United States and in Germany to really scale up manufacturing and bring back manufacturing and reshore it. So I think tools like yours are definitely necessary to really become a more scalable industry. And, when we've also talked in the past, and I think it was a few months ago, you mentioned that you started 1000 Kelvin at a very interesting point in time where additive manufacturing has reached a critical maturity. It has kind of evolved out of prototyping. We're in production now. But do you think there's another step that has to be made, which is to move towards true material processing?
Yes.
Can you elaborate a little bit on what you mean by that and how you view that transition?
Yeah, so I thank you for bringing that moment in time, because also it was an interesting moment in my career. I started doing AM. I spent a big time of my professional career working on building AM technologies, and at a certain point, I was like, well, we reached the ultimate level, and I decided I want to see something else, and I went to semiconductor. I spent a few years in the semiconductor industry, and it was like eye-opening for me how AM is not yet born, in my view, at that time. The level of automation, precision, knowledge of material transformation, measurement, KPIs, as well as yield as parameters, those all kind of were not something I have been seeing all over the place. So it came to me, maybe that's what triggered the entrepreneurial side of myself and my co-founder, is that there is a big opportunity. And I think there is a massive opportunity in AM for all of us. Now comes that statement that we all make. We hear every conference, in every discussion. I want to move from prototyping to serial production. Of course, that's the holy grail of the AM. But let's be honest, there is a step in between that we are all missing. Okay, I don't want to say all, because I think all of us are aware of it, but we didn't address it properly, which is how can we take an exciting technology where we have reached a level of maturity in the systems, in the materials, to a materials processing discipline? How can we produce components, controlling the process and the recipe so that we yield to a microstructure and properties that make that component qualifiable again and again in a repeatable, consistent manner? And I think this is really the biggest topic for the next 5 years. And obviously, this requires a lot of intelligent people, a lot of investment in R&D. But what we are claiming from 1000 Kelvin is we will need a lot of AI. And without AI, we will not be able to do it. Think about it, Fabian, you know this better than me. An AM process is, we're talking about layers and millions of vectors and changing process parameters and corners and geometries and materials. It is extremely difficult to understand the full thermal signature in metal or in polymer or whatever. So only by going to the fundamental understanding of the intricacies of these processes, combine them with the knowledge in materials and the stability of system, then we can call ourselves a materials processing discipline, which I don't think we are far from that. So by implementing this materials processing as the way to go, we will be able to reach, with a lot of confidence, serial production.
No, I totally agree. For the past 5 years, I think the game has been, how can we add more lasers to a system? How can we reinvent the technology and put a different technology out there? Those were really the main talking points in additive manufacturing. I think today, what at least we're focusing on a lot is how do we really ensure continuous repeatability and reliability of this equipment? So really moving towards material processing. And I totally agree with you. It's a very complex technology where you're making millions of micro welds throughout a build, and having a co-pilot that can, prior to running a build, simulate that and really understand how can we improve the application to get the best outcome and the most repeatable outcome, I think is definitely key. Can you talk about a few use cases where your customers are using additive manufacturing, and what kind of output they're getting from it?
Yeah. So just to be consistent with the claim that AMAIZE is Copilot, getting a little bit into the technicalities. So what we provide to our customers is a thermal management platform. So AI is the engine behind, but in reality, it's an engineering tool that helps you predict, see where the thermal issues will be. You can use these data to do microstructure prediction. You can do it to reduce amount of support. You can do it to design and print intricate geometries. So we provide you with the platform, and you come with your business case or use case on the top. So
Mm-hmm.
actually, as a matter of fact, we learn a lot from our users because they push our tool to the boundaries. So you asked me about few use cases that we see recently. I think all of us know that when you are 3D printing, especially in metal, uh, complex geometries, this leads to warpage. And we all know, and we should stop lying to ourselves, that there will be one day a component without warpage. I mean, residual stresses are inherent to any manufacturing or material processing technologies. Now, the question is, can we understand what is the driving force behind this accumulated residual stress? And if we understand that, can we find a way to solve it? Well, in metal AM, for example, it's mainly a thermal process. And if you have a massive delta T, then you will have an accumulation of residual stress. Can we homogenize that print so that we minimize them? And we see every week customers able to reduce the amount of distortion to an acceptable tolerance without having to anchor or compensate the design and things like that. So this is one use case. We see customers also trying to work on the cost per part. They tell us that post processing is 20 to 30%. If we can help them reduce the amount of support structures, then they will be able to produce that. So they use our tool to manage the thermal better and produce surfaces with reduced amount of support. I can continue. I mean, of course, thermal bottlenecks in copper and very large geometries where you have the mix between local and global overheating are challenging. So we provide solutions for all that. So I think those are the main use cases. Obviously, we're working on exciting other topics, but yeah.
Yeah. And I can imagine that your tool has one additional benefit, which is also onboarding new engineers that have a conventional manufacturing background, possibly, into the additive manufacturing space can take a while. And especially the thermal response of a part within a build is something that kind of takes experience. You got to have builds on your belts in order to really understand and apply that.
Yeah.
So I totally believe that your tool can also accelerate the onboarding of new engineers as application engineers, and therefore reduce or increase the efficiency of a team during that process.
Obviously, from a macro level impact on small teams, our tool is obviously helping companies reduce the dependency on experienced people, onboard quickly engineers. There is a massive cost related to NRE, non-recurrent engineering, that these companies have to take before they get to a successful project. We try to reduce it. We help companies reduce the amount of physical iteration to digital iteration. So from a P&L perspective, you know, again, it's not about AMAIZE. I mean, I can see this across the board. We're also using AI every day in our development. Those are the natural savings or efficiency enhancement that comes with such a technology. And we need to be aware of it, accept it, and adopt it. That's my message.
Yep. Yep. No, I totally agree. Now, our industry is sometimes very interesting, where we have very innovative technologies, and these are evolving rapidly. But then we have sometimes organizations, especially in restricted industries, that don't move that quickly. what is your point of view on using AMAIZE in the development of an application, but also ensuring that I can push this application into production and reducing my risk of walking into barriers when it comes to actually qualifying a part? Because now I'm really developing an application-specific process where I may not have any legacy data to prove repeatable part properties.
Yeah. I mean, first of all, I think that these high-end users that you're referring to are world-class companies, and they are experts in material processing. I think they know what they're doing, and they have been telling us this message for years and years. Guys, in order for us to do what we want to do and grow the business, you got to do this and that and that. And one of the topics they ask us to do is how can we give them more technology, more flexibility, more openness for them to be able to qualify this component. At the end, they understand the function of the component, and therefore they know what kind of properties this component should have. So specifically to us, and we're working with these kind of companies, many of them, without mentioning names, they are using our tool. They are coming to us and leveraging the openness of our tool. You guys do the prediction. We know how we want to do the correction based on our qualified process. Can you do a specific correction to me that does not change power and speed, but changes other things, for example? So I think that they have been asking for technology progress, which we are doing, all of us. But now they need that openness also for them to be able to put their knowledge on the top of this and be respected as mature processors. And that's what we see. I see, at least from our side, the opportunity, working hand in hand with them to propose a platform where they can build instead of just another tool that they just acquire and try to figure out how it works.
It's an interesting aspect. We're currently exploring AI more for service and customer support use cases, where ultimately you start at a certain baseline where you have documents, you have operation manuals, service manuals, etc. But you come to a point where you need to start training an AI on organization-specific use cases. Is that also something that is possible with AMAIZE, where we can now also implement organization-specific databases and certain knowledge?
So besides the base solution that we provide to people that already is quite rich, we see two areas where people are coming to us. Number one is specialty materials. Obviously, the core things we do is we develop machine learning algorithms. In order to develop this algorithm, we need to generate millions and millions of data points. And that's the hardest part of our R&D activity. So they come to us and they're not asking us for the traditional titanium 6.4 or Inconel 718, but they're coming with a new formulation. I don't have that off the shelf. We need to go and train it for them. So yes, this is one of the type of request. And the second, obviously, is these companies come with very defined procedures on what should change and what not in terms of adapting the recipe. I like to use the word recipe. So I'm going to use titanium 6.4 to produce different type of components. Yes, I do understand that you need to manage the thermal for me to have the consistent microstructure, but please don't change power and speed, for example. What does your API in partnership with your OEM offer us to tweak in order to achieve our goal? And this is also where we have a very nice, healthy discussion with the OEMs, where we show them this is the end goal. Can we flexibilize this towards the customer? And I think it's happening. It's a day-to-day business.
Yeah. What role do partnerships play for you guys? I mean, obviously you're creating such an important piece of the puzzle, but it's hard to do that alone. I know there's a partnership between EOS via EOS Print. You guys just announced a partnership with Autodesk. How are you building this ecosystem of companies to really ensure that the end user isn't just stuck in the middle?
Yeah. No, actually, what we share with these companies, you have mentioned, taking the example of EOS, yourself being a part of that organization, is we share the capacity of listening together to the customer. So it's not a discussion just internally between us alone, separate. We actually listen to the customer and we go on. There is a kind of confidence between our capabilities and complementarity. And then it's so obvious within a logical organization that the value creation will be high for the customer. It's a win-win. And those things happen naturally. I would say specifically with EOS, we're working with the colleagues for many years. We have worked together on developing this. And again, the objective was never to give us something or to give EOS something. It was about how can we deliver something superior to the customer based on their request. So I think the blueprint is the same. I would say the same thing for our collaboration with Autodesk. We share the view, as you said, that we need to democratize and simplify the workflows for young engineers. Can we bring them as many tools as possible early so that they are successful and they come to manufacturing and additive manufacturing specifically? So again, it's really partnership. The blueprint is partnership, focus on bringing value, superior value to the customer.
Okay. So what does that now look like for an engineer out there? Let's say Jim Bob wants to build a quite challenging application. It's not really optimized for additive manufacturing because it's a spare part for a critical application. Let's say in the oil and gas industry. What does my workflow look like, and how does the Copilot assist me in making certain decisions to ultimately have a first time right built?
Yeah, that's so obviously not all the engineer are the same. It changed on within industry. Like when I talk qualified and highly searched, regulated industries like medical and aerospace, that's a totally different story. Those gentlemen and ladies want to control everything and want to do pure material processing. And they have tons of requirements that are different from a company that's have a business case on spare, lead time. And I appreciate the example you said, because we work with a lot of those folks and we are very proud to support them. They typically come with a business case related to, I want a part tomorrow. And this part, you have been casted. So it's casted design, not really the best for AM. And the solution they had to use in the past was the so-called modification for additive, not design for additive, but modification for additive.
Sure.
So what we see and what our customers are telling us is with our tool, without changing design, we can go and play on the recipe, the scan strategy, the timings, and all those intricate features so that we can make it printable. We have a lot of success in valves, for example. We see a massive increase in the amount of valves, closed impellers, open impellers in the oil and gas, where they just literally want a recipe so that they can print it instead of having any modification. So you come with your design, you have your G code, let's call it G code, not to be specific. You open 1000 Kelvin platform, AMAIZE, you drop it, we analyze it, we show you where the issue is, we tell you how you want to correct it, you tell us what you want to change and what not. And then we will go and apply that correction iteratively, computationally, until we find the right new recipe that will make it print, and you can download it and go to your machine. So the workflow is extremely fast, brutally efficient. It's almost like you get it on a WhatsApp message. It's done. You can go and print your part. So this is really where we're heading. More automation, more intelligence, and keep the engineer focused on what's the most important.
Is that where you see the at least greatest immediate impact is in enabling organizations to build up supply chains for parts that are conventionally designed, where there might even be a conventional supply chain, but there's lead time challenges. And I don't want to make any design modifications because A, it's part of a system, and also B, that takes very much time and possibly a requalification of the application.
So this is a great question, Fabian, because the reality is this supply chain, parallel supply chain, digital inventories, you find this in every country. Every country you go to, you will find an ecosystem for spare parts on demand. Now, the main challenge we see that these folks are facing is when they go to the catalog of their customers, they can only find 5% of those parts that are really easily printable without changing. So how can we change it to 25%, 30%? Not any design. So that's where we are tapping now in the opportunities. That's where we are very active, and we're really proud to support those guys.
Yeah. I think, the past 5 years, we've seen a lot of beautiful parts at trade shows, beautifully organically designed, and sometimes with limited use cases. I really hope in the next 5 years, we see boring parts that 5 years ago, we would have never dared to put on a trade show. Because that's really where I think immediately there is a lot of untapped potential in organizations to switch over their supply chains, make them more agile, because the next Red Sea Houthis attack, parallel incidents going to happen, and we'll have the next disruption in these complex supply chains.
Yes, absolutely. And Fabian, I know you know that there are a lot of those boring parts all over the place. It's just that marketing department don't accept those pictures. But the industry is like, a lot of people say, well, the state of the industry. I think that there are good, healthy trends in our industry at the moment, because as you said it yourself, people are focusing on the value. The value is not the parts, and it's how beauty, it's the lead time, it's the cost, it's, the system level. I remember this is one of the first use case that really, really was so impressive to me as a young engineer when I was in the field in the middle of Saudi Arabia as an operator for a drilling platform. And I saw, what does that mean? A spare part missing. It's like millions per day lost. So like the business case, business cases are like this, are all over the place. We just need to make sure we're able to serve them.
Yeah. You mentioned marketing. It seems to me that throwing the term AI into a marketing message right now is a great way to create some attention. What is your perspective on the misconceptions on AI that you encounter every day? I'm sure there's both levels. There is really an underestimation of its capabilities, but there's probably also the other extreme, which is overestimating the capabilities of artificial intelligence, machine learning, even large language models. What is your point of view on that, especially when we talk about manufacturing and additive manufacturing?
Yeah, well, I mean, look, obviously, if you go to the finance world and you talk about AI, they don't question anything. It's all over the place. Obviously, that's a different type of industry than ours. It's a physical industry, and people tend to judge based on atoms rather than bits. They want to see the physical outcome. To be honest with you, we are in the heart of AI revolution, and we are not having that problem because our end customers are engineers, and engineers, they know what they're doing, and they can quickly learn and see what's going on, and they can see the value. So I do think that obviously there are a lot of companies out talking about it. I do understand it. Valuations, attractivity to investor, all those are high level things that engineers, they don't need to deal with on day-to-day basis. My customers are the engineers. So for me, it's rather a straightforward discussion, and they generally understand the fundamentals quickly. And they ask us, obviously, what's the difference between what you do and the simulation? How does that, how is it fast, and things like that. So we're able to provide them with elements. Now, this said, I do think that AI has obviously limits. There are multiple limits. There are inherent limits, the amount of data available to even create some value. There are limits related to, use cases. Sometimes it makes more sense to keep humans in the loop. So those are company to company specific. However, what I'm worried about, and I see it sometimes, is we tend to, especially in the AM, we have been, I think our leadership, the leaders out there are tired of overpromised and promising, and they tend to push back. And I'm afraid they miss this opportunity. I myself, in our business, besides what we sell to people or what we develop, we're using it on day-to-day basis. My engineers have increased their productivity massively. I actually spend my time sometimes with my co-founder measuring the productivity increase, and it's mind-blowing. So I wish everyone get that benefit in their organization as soon as possible.
Yeah, no, totally agree. And it has an impact on all disciplines within an organization, from marketing to accounting to obviously engineering, supply chain. Couldn't agree more. Now, obviously, this is also just the beginning of what 1000 Kelvin is doing, what AMAIZE is capable of. What's the next big thing for you guys? You're working on really eliminating the overheating challenges, or at least helping engineers to get way more detailed insights into challenges of their application design and how to get around it. What's next?
Well, I mean, look, we are still, most of my team is very German. And, there is something about us that is very German. That is Schritt für Schritt. And
Yeah.
that is a philosophy that we have. We like to bring a technology and develop it, test it, break it, and until I see my customers making, a massive ROI from it. And then we can think about the next. So at the moment, we are extremely focused. We think the industry needs us because we are really bringing some value that is needed. And we want to be here and focus on the industry. This said, think about it. I'm passionate about manufacturing. I've been doing manufacturing since my first job. And AM is a niche of a niche of a niche compared to the rest. And believe me, every process have the same issues. At the end of the day, machining, forging, milling, stamping, all of them are some amount of energy or shapes applied to a material and it transforms. So I'm really excited because we build a backbone that is translatable to other manufacturing process. We're looking at DED and WAM now. We're coming there also. We have some nice partnerships.
Mhm.
So a mix of excitement about next manufacturing process, but also focus on delivering value to our customers in LPBF.
Very, very interesting. Yeah. Seems like a natural transition into other technologies, not only in the additive space, but also in the conventional space.
Absolutely.
Sure.
Yeah.
Well, Omar, it was very insightful to
Thank you.
talk to you today. I think we had a great discussion. Thank you so much for being on Additive Snack.
Thank you for hosting me, Fabian, and see you soon.
All right. Well, this was it for this week's episodes. To me, it's clear that AI and additive manufacturing is a very natural marriage of very innovative technologies. And with people like Omar and companies like 1000 Kelvin, I think we'll see a continuous acceleration of the adoption of additive manufacturing. I think all what we've discussed today, from helping engineers to innovate faster, helping companies to identify more parts because limitations are now removed, really should accelerate the adoption. So I'm really excited for that. I hope you enjoyed this episode as much as I did. So don't forget to subscribe to the Additive Snack podcast on your favorite platform to stay up to date on the latest and greatest in additive manufacturing. I'm Fabian Alefeld, and I'll see you next week.